Hello everybody. This is going to be a short video, hopefully a short video, on how to do a regression and different types of regression on the Nspire calculator. I'm also going to do a video on how to do the same exact problem and the same regressions on Desmos, so stay tuned for that one if you prefer to use Desmos instead of the Nspire. So maybe grab a piece of paper so you can write down a couple of the key sequences and stuff like that. I'm also going to use this problem. It's a short data table, but the process applies to however long your data table is and whatever kind of function it is. Like in this question, we're not even sure what kind of function it's going to end up being, so we're going to do a couple different tests on that. So I'm going to bring up my calculator, my emulator here, and what you want to do, you want to always start off with a new document. So just hit the number 1, open up a new document, and the first thing we want is number 4 for lists and spreadsheets. Now before you do anything else, make sure that you're up here at the top of column A and type in X for your X variables, and then do the same thing for the top of column B and type in Y. Don't put anything in these spots at all. On the line with the equal sign there, do not put anything there. And then as you get down to the main body of the spreadsheet, type in your data. And again, if you need to go back to the beginning, I had that data table on there. I'm going to type that in now. So my X values are 0, 5, 10, 15, and 20. And then my Y values are 10.2, 2.9, 8.2, 16.1, and 17.9. Once you get those in, it's a good idea to double check that you didn't have a case of the fat fingers like I do all the time, and make sure that the values are what they are on the table, because even a slight difference can throw off some of the results and how closely the different kind of functions are going to align. So make sure you double check that. Once that's all set, we're going to add a page. So anytime you want to add a page, you want to hit Control and the dot key. And now we're going to do data and statistics, number 5. And you see the dots like in random places. So you want to use your little mouse pad over here, come down to the bottom where it says click to enter, and we're going to obviously choose X for that axis. And then on the far left-hand side, do the same thing and choose Y-axis. And then you're going to see what the scatter plot looks like on a reasonable scale. So we see that, and I think you can agree that this is not going to be a linear regression. But I'm going to show you how to do that regardless, and kind of show you how we can find a linear equation. If you do want to use that, I'm going to explain how you can really tell why it's not going to be a great choice. So we're going to hit the menu key, go to Analyze, and where it says regression, so menu 4, 6, and if you want linear, and you see all the choices here, and there's even more below here, but for linear, we're going to choose MX plus B, since that's kind of the normal format, and it's going to throw the line up there, and you can see there's the equation, and you can see the dots are not super close, but sometimes even with the scale, it's a little bit hard to see how close they are, so there's another trick we can do. It's called finding the residuals. So we're going to hit the menu key again, go back to Analyze, and now number 7 under Residuals, and you're going to do number 2 for Show Residual Plot. I'll do that one more time real quick. So again, Analyze, Residuals, and then Show Residual Plot. And when that comes up, it's going to split screen it for you. So we still have our normal graph up here with the line of best fit. And this, let me get my face out of the way, this 0 line right here. This is the line of best fit. And what these dots are, this tells you how far away our data point is from where the best fit line is. And you can see as I kind of hover over these, they're not super close. And notice, by the way, the X values are still our normal inputted X values, whereas the Y value is how far away it is from that line of best fit. This last one isn't too bad, but these first few are not great, so I think we can do better. So I'm going to get rid of these things, so this is a little bit tedious, so bear with me. We got to go back to Analyze, Residuals, hide the plot, hit Menu again, go back to Residuals, Regressions, and then we're going to hide linear, You could do it one after the other, but it's going to be a mess, so I'd recommend hiding them and doing the next one. So what if we want to check on a quadratic? This looks a little bit maybe like a parabola. You can make it that argument, so let's do a quadratic regression. So this is number 4. And you can see this is definitely better. Let's check the residuals. And so back to number 7 and show residual plot. And we have this, and now we check these, and these are way closer already. So you see the 1.89, negative 3.8, that's not great. That one's really good. And again, they're all closer than some of those ones who are on the linear plot. So this might be a good choice, so I'm going to keep that in my back pocket. And I'm going to check one more. I'm going to check a cubic regression and then see what that looks like too. So again, I got to go back and hide all these things so it's not a complete mess. So hide quadratic. And now we're going to do one more. We're going to do the cubic model of the cubic regression. So one more time, back to analyze and regressions. And I do want you to notice real quick that the residuals here is actually grayed out. You can't even do it until you choose a regression for it to test. So the last one I'm going to do for this one is going to be a cubic model. And you can see just the eye test that it's pretty doggone good. It's hitting those dots pretty well on par. So let's check our residual plot. And you can see these guys, we're well inside of 1 for every single one of these points. So that's what you're looking for. And you'll also notice, this is more of a general term, especially when you get a bigger data set, we kind of want the residual plot to look like there's no real discernible pattern to it. We want them kind of scattered about kind of in a little random order there, and that's kind of what it looks like. So I've definitely decided I'm going to use my cubic model for this. And we see the equation right here, but to avoid, and you might have to write it down depending on how the question is phrased, if it's an F or a Q or something like that. But usually you're going to want to just store that so you can use it for some predictions and some modeling of that data. So here's what I'm going to do. I'm going to go back to my spreadsheet. And now that I've decided on the cubic model, I'm going to hit the menu key, go to statistics, go to stat calculations, and I'm going to choose the cubic regression. Now, this is going to do the exact same calculation for the equation, but there's a little side benefit to doing it here. So on the X list, obviously you want the X variable. Y list, you can choose a Y variable, and you don't need to change anything else. But the important thing I want to point out right here is where it says F1. This is going to store this whole equation, all the decimals, into the graph, into the function F1. And I'm going to show you how useful that is in just 1 second. So this gives you these specific values for A, B, and C, and D in this case. And then down here, I want to point this out too. This is a value we call the R-squared value. And the closer that is to 1, the better fit your model is. Okay, I'm not going to go through the time and do that for the quadratic and the linear, but it would be much, much farther away from 1 than this one is. You can see 0.9998 is pretty doggone close to 1. So that's definitely a good model that we can use to make predictions. So speaking of those predictions, how are we going to do that? So we have our model, and again, all of these numbers are stored in the calculator for you. So I'm going to go back here, I'm going to open up another new page. So again, Control Doc, and this time I'm going to do just a calculator page, because let's say our table of values had X values of 0, 5, 10, 15, and 20. Let's say I want to make a prediction of when X was 7, or even some kind of weird decimal like 7.3. Well, all I have to do is come in here and type in the letter F1, and you see how it turns bold. That tells you that the calculator knows what that is. And then just open up a set of parentheses, type in whatever number it is you want to test. And again, I'm just going to make one up at 7.3, and you hit enter, and there is your prediction for when X is equal to 7.3. The prediction, that line of best fit, is saying that the y value will then be 4.36 and so on. And you can do that for any number you want. And again, every time you type in F1, it's going to become bold like that. And you can type in any number that your heart desires. Let's do 21.1. And there's that value. So you can do that for if you want to test a different x value than what is in the table. But what if you want to find the x value? What if you're given a y value and you want to know what x value that would be predicted to happen at? In that case, we would open up still one more page, last one, I promise. And this time I'm going to go to the graphs. And you'll see when it opens up, it's going to shoot you right to F2. Well, just hit the up arrow on your mouse pad, and you'll see that entire equation, all the decimal points you could ever ask for, is sitting right there. So just hit enter, and you're going to see this, and you're going to have to do some window adjustment. I'm going to use window 4.1 to manually change the settings, and I'm going to use the numbers in the table. So I'm going to change the x max to like 25, a little bit more than my maximum max on the table. And I'm going to change the y max to, I'm going to do 25 also in this case, just because it's bigger than 17.9. And then hit OK. And there's my graph right there in a reasonable window that I can use. Of course, I can change it again if I need to, depending on what I'm trying to find. Another little trick, you can use your mouse pad, and if you hover over the equation, it turns into a little hand. If you long press the center of the mouse pad, it'll grab it, and you can just get it out the way because you really don't need it at this point. And then, let's say we want to test a y value of, I don't know, let's say you want to test a y value of 12.5. Well, just hit the tab key and type in that y value into your F2 equation, hit enter, and it's going to draw a horizontal line, and then we can use the analyze graph, so menu 6, and intersection, and we can find any one of these points. So when the y value is exactly 12.5, we can find our x value. And if you need to change how many decimal points it displays, of course, you can do that through settings and change the float. In this case, I'm going to leave it at float 6 because 3 decimal places is good enough. So that is doing a regression. And again, this works on any kind of data set, and you can do any kind of regression you want. You know, right now we're dealing with polynomials. Later on in the year, we'll deal with exponentials and logarithmics, and we'll even get into some sinusoidals towards Unit 3 in AP Pre-Cal. So I hope you enjoyed this video. I hope you found it helpful. Feel free to come back to it and reference the different steps as you need to. And until next time, take care.